All right. Hello, everyone. I hope that you are excited for our virtual learning day. This is our advanced geometry attempt at doing this lesson without you actually being in the room. All we're going to try to do today is introduce you to a main topic that's going to actually be found in 3.6. Now, we'll come back. When you guys come back, we'll do 3.5. But for now, I want to give you some examples of some problems we're going to see in 3.6. So 3.6 basically asks the question, if I give you a line and a point, what is the distance between that point and that line? Now, I'm sure you guys know the shortest distance between 2 points is a straight line, right? Okay, so then you're probably thinking, all right, the shortest distance between this point here and this line here will be a straight line. Well, there's a lot of straight lines that get me there, right? Those are straight lines, those are straight lines, those are straight lines, those are straight lines. And the question is, which straight line is the best? And so I'm sure a lot of you kind of realize the best way to get there would be to go straight down to it. That would be the shortest of those lines. But the reason why straight down here is the right answer is because if this line is horizontal, then you're actually going to draw the line from the point that's perpendicular to the horizontal line. So that's the key, guys. The shortest distance between a point and a line is the perpendicular distance to that line. You have to follow that perpendicular. So hopefully you guys can see why this section relates to what we just did with slope, right? We talked about how if lines are perpendicular, they have the negative reciprocal slope. So here's an example of an application of perpendicular slope. If I give you a line and a point, you can find the shortest distance by finding the line that goes through that point that is perpendicular to the given line, okay? So I shared a worksheet with you, and if you don't already have that pulled up, you might want to. You probably want to take these notes on a blank sheet of paper, and then you can write this in later. I'll actually hand this to you in class at a different day, but for now, you should just do this on a blank sheet of paper while you go, okay? So notice what the directions are going to ask us to do. They're going to give us a point, and they're going to give us a line in slope-intercept form, and they're going to ask us to find the distance between that point and that line. So what we're going to have to do is, we're going to have some line and some point, and what we need to do is we need to find what's perpendicular to this line and find that perpendicular slope, and then find the equation of the line with that new slope through the point they gave us. So it's easiest to break this problem up into 3 steps. You do step A, step B, step C. We're going to do these 3 steps every single time. So the first step is this. Find the equation of the line that is perpendicular to the given line, which is that line right there, and goes through the given point, which is that point right there. Okay? So let's look. The original equation, we're going to call this the old slope. The slope of the old equation, notice it's y equals mx plus b, where that's like an imaginary 1 right there. So my old slope was 1. So my perpendicular slope then is going to be the negative reciprocal of that, which is going to just be a negative 1, because the old one was 1 over 1, so if you flip it, it's still 1 over 1. But now it becomes negative. So there's your new slope. All right? So now I have a slope and I have a point. Can you write an equation of a line given a point and a slope? Of course you can. Use point-slope form. Y minus 2 equals negative 1 times x minus 3. Now, I'm going to tell you, and I'm going to put this in the directions, you're going to want to make this into y equals mx plus b. So we'll do that now. We'll turn that into y equals mx plus b by distributing our negative, and then we're going to add 2 to both sides, and I'll get my new equation, y equals negative x plus 5. That is the first of our 3 steps in this problem. Our new equation is y equals negative x plus 5. There's the equation of the line that's perpendicular to the given line through the given point. So we just found this equation, all right? This equation that goes through that point that's perpendicular. All right, now for step B, they want me to find the intersection point of the new perpendicular line and the original line that was given. So remember, my new perpendicular line is y equals negative x plus 5. So there's my new equation. And now I want to find the intersection between that new equation and the line they gave us to start with, which, if you look back up at the top, was y equals x minus 7. So the other one is y equals x minus 7. Now, notice how I've written those out. I've lined them up Because what I want to do is I want to find the intersection point, which really means I want to find the solution of those two equations. There's a lot of ways we can do this, guys. We could do substitution. We could do elimination. Both of them are fine, and actually both of them are very easy in this case because they're already set up so well that the x's are going to go away. A minus x plus an x is just nothing. So I'm going to end up getting 2y equals a negative 2, which means that y equals negative 1. Okay, so now if I have my y as negative 1, I can plug that back into my original equation, and I get negative 1 equals negative x plus 5. I'll subtract 5 from both sides. I'll get negative 6 equals negative x, so then x just equals 6. So guys, my intersection point of those two lines, the original line they gave me and the line that I found that was perpendicular, is 6, negative 1. Okay, so now look at C. Now they want us to find the distance between the intersection point we just found in B, which is that one, so 6, negative 1, and the original point that was given, which back up at the top was the point 3, 2. So let's do that now. So I have these 2 points. I have the point 6, negative 1, and the point 3, 2. And they want us to find the distance between them. So don't forget, our very first note card of the year, the distance formula is x2 minus x1 squared plus y2 minus y1 squared. And I'm going to plug these points in. So here we go. 3 minus 6 squared plus 2 minus a negative 1 squared. Well, that's going to clean up into a negative 3 squared, which is 9. And that's going to clean up into a 3 squared, which is 9. So I get the square root of 18, but I'm not going to leave it like that. That's the same thing as the square root of 9 times 2. The square root of 9 is 3, and you leave the square root 2 in there. So there is my final answer. You just found the distance between the given point 3, 2 and the original line that they gave us. And we found that distance by finding the line that's perpendicular to the original line through the given point. All right? So there's one example, and now you can watch the other video to see another example, and then you'll try some of these on your own.